I'm going to summarize for you my presentation on using the theory of constraints to boost a lean organization. So I'm Philip Marris. I started my theory of constraints journey about 26 years ago when I joined Creative Output in 1986 and worked with Ellie Goldratt, among other people. Today I'm the CEO of a management consultancy firm based in Paris, France, and 80% of our work involves helping industrial companies implementing theory of constraints, in particular in manufacturing. I'm also the author of a very boring French book on implementing theory of constraints in manufacturing called Le Management par les Contraintes, and I'm the administrator of the TLS LinkedIn group also, and a member of the TOCICO French regional board. I'm going to talk to you today about a case study which was something we did last year in 2011 in Mexico, in a very working for a very large automotive equipment manufacturer, one of the 10 largest in the world, and also reputed to be one of the leanest organizations in the world, necessarily among the 30 best practices in terms of lean manufacturing in the world. They asked us to help them in one of their factories in Mexico. They had a problem which was quite simply that they were not managing to produce enough. They'd had a fairly low demand for their products in the previous years, and suddenly the demand had boosted up, in particular for in America, but also in the rest of the American continent. And so they just couldn't produce enough, and they were having a lot of trouble with their clients, having to send all their products by airplane all over the continent, which cost a lot of money. And even doing that, they were getting it late. And for instance, one of their major customers, one of the largest manufacturers of cars in the world, had sent a resident team in 24 hours a day to put pressure on the factory to make sure that they would produce and honor their orders. So this was for the whole firm the hot spot in the company. They'd already sent 10 of their best world managers to the plant to make it work better. They'd basically tried everything, and so in total desperation they asked me to try and help them by injecting theory constraints into their system to see if we could produce more in that way. So we went in there. And the factory's about 1,000 people, broken up into 20 autonomous production units. We did a very rapid, simple, unambiguous identification of which of the 20 production units was the bottlenecks. We identified two and a half of them as being bottlenecks, and I'm just going to describe what we did in one of these bottleneck areas. The bottleneck UAP can be summarized in this way: a dozen operations. The products go in here, go through various operations, and come out here. Okay, we're talking about car alternators, so we've got parts that are about this big that travel around in this way. This production unit with about 10 people produces about 6,000 units a day on a 24-hour basis. That's about one product every 15 seconds. They had already, this is part of their production system organization, formally identified their bottleneck correctly with a sign next to it saying this is the bottleneck, and so that's where things started. So I spent some time just doing a Gemba walk, standing around trying to understand how we could improve the performance of all this. And so what we did is implement one of the rules of the theory of constraints, about 1 or 2% of the whole principles of the theory of constraints, and that improved the throughput of the performance of the unit by over 15% in 15 minutes. So the question is, how did we do that? What rule did we use? Okay, this is a standard, very lean U-cell in a very lean organization. The machines were working well. There weren't many quality problems. So how could we go further? They had one-piece flow all the way around through here. Everything seemed to be working okay. The pressure was on, and it was working 24 hours a day, more or less. So how could we do it? Well, for all the practitioners, it's fairly obvious what we did. We just added a buffer here in front of the bottleneck. Okay? And in 15 minutes, all we did was just change the rules, and we said there should always be at least 4 parts here. That's 4 times 15 seconds, about a minute's worth of work. Okay? And that was enough, 12 parts representing 3 minutes of work. And that was enough to absorb all the micro stoppages that were occurring on this unit, and that ended up, in fact, being 17% increase within the hour on a stable basis, simply because they were getting lots of stoppages from this resource, which was a non-bottleneck, but not that reliable, and therefore we were losing quite a lot of time here. Okay, and so that's really as simple as that. We did this sort of thing in other parts of the organization, and what is remarkable in what was done there is that we had to think again, important rule of the lean manufacturing organization, which is called one-piece flow. You will always have one-piece flow throughout the factory, and we changed that by accepting that there should be a very small buffer of just a dozen parts. It would just fit like this much in front of you, and that made a big difference, 17%. Okay, we worked further than that. We didn't only do that. We worked in such a way that overall, doing this sort of injection, that and other things increased the production by over 30% in the 1,000-person factory within a couple of months. But this one was extraordinary because obviously the results were more or less immediate, and everybody was very surprised. But it was painful for them because we had to break this rule that was written in their Bible, one-piece flow everywhere. And so that's the main message I wanted to bring across. Just, TOC injections in a very lean system, if they're the right place at the right time, can make a big difference. And this obviously was a message to management. We've been discussing things since, how to integrate the theory of constraints in their X-production system, so that they could repeat this throughout their 110 factories in the world. If I chose just this simple example, I could talk for days about this subject, but the point was, here is an example where theory of constraints plus lean is an equation where it's 1 + 1 = 3, and I think we should be trying to do this as often as possible because it's important given the importance, the market share of lean in the world today. Thank you very much.